Thanks. Okay, so we had seen some basic stuff with Xarray computation. Let us launch this. Too many users. Okay, so they are saying that there are too many users, so we can try it from this example. So did we cover this example, plotting and visualization?
No, sir.
Did we cover this? Yes, no. Does anybody remember?
No, sir.
No, sir. No, sir.
Okay. You don't remember, or we did not cover?
Sir, we did only read the data and
Sorry?
We did not cover.
plotting the
Can you be a bit louder? Yeah.
Plotting is not done, sir.
Yeah, can you be a bit louder? Hello?
I think he said
Okay.
plotting is not covered, only reading and.
Okay. Yeah, fine. Yeah, so we covered, I think, data set, data array. What is a data set? What is a data array? The syntax of that. So yeah, maybe that will repeat
Sir,
briefly. So yeah.
sir, can we use nan as a key in dictionary?
I don't think so. How can you use nan in a dictionary? I think as a key in the dictionary, I think maybe if you are using, then try to use only once.
Only numbers?
Try that. I mean, I'm not tried. No, I am saying I can't rule that possibility out. Try that, but try to use it only as only once, only as a, so key should be unique, right? Am I audible?
Yes,
sir.
sir. Yes.
Yes, sir.
Okay. So okay. So we saw in the last class how to create a data set and the syntax for a data array. So we can see that you basically have the name of the data array, and then you pass the dimensions as a tuple, and then you give the numpy array, right? So you can give as many variables as you want. And to create a data array, so you have to give, the first thing that you have to give is a data set can have many data arrays, whereas data array corresponds to a single variable. So in a data array, you can see we can have this numpy array. So we define the dimensions. The keyword is dims. You define the coordinates, which have same name as dimensions, but they are also having the values. Then you have the cell and I cell, which are similar to log and I log in pandas. So with cell, you can extract the values for corresponding to the actual values of the coordinates. But with I cell, you would need to give the index, and you can Xarray also gives you a functionality wherein if you don't have the data at a particular combination or at a particular coordinate, then you use this keyword method equal to nearest, and it will give you the nearest grid point value. So then will see, okay, so Xarray comes with this kind of preloaded data set of air temperature. So yeah, just give me a minute. Yeah. So yeah, so Xarray basically comes up with this preloaded data set for its tutorial purposes, which is the air temperature data set from NOAA. And so DS is your data set. It has got 3 dimensions: lat, lon, time. It has also got the coordinates, so you can see the yeah. So we have lat, lon, which are the coordinates, and we have the time. So the data array or the variable here is called air. So the name of the data array is air, and we saw last time that you can very easily use this interp function. So dot interp. So it to basically interpolate the data set over a different grid or over some points over which you do not have the original data. And also you can do the use this function interp like, so interp underscore like. So if you say arr, which is a data array, okay, dot interp like, and you pass another data array or another data set, so this will interpolate arr in the grid of other. So then we have the broadcast and automatic alignment. So if your dimensions and everything else is same, so for example, we are talking about a variable air, which corresponds to the air temperature. So if you also have like pressure or precipitation, uh, so you can do this operation a plus b, and it would just broadcast in all the dimensions. So that's on broadcast. And how you would do the computation. So let's say we get this data set ds, which is having lat, lon, time, and the data variable is, the name of the data variable is sst. So the times, so these are the dimensions, and yes, we see 89 cross 180 cross okay, 708 cross 89 cross 180. So you can very easily plot particular snapshot. So this is a three-dimensional. So to access a variable from this, so this is ds is your data set. To access the variable sst, you have to say ds dot sst, and now this contains so many different times. So to access the first or to slice the first time, so you would just say 0 because the first dimension or the first coordinate is time. And now this is a uh, two-dimensional data array. So you can just say dot plot. Xarray automatically understands whatever you give it. You give it a three-dimensional data, it will plot a distribution. Two-dimensional data will plot a spatial map. One-dimensional data will plot a time series. And you can pass the vmin and vmax arguments. So you can see that Xarray has picked up the long name, the time at which this plot is, the long name of the latitude and longitude, and the name of the long name of the variable for the color bar. So you can also do basic arithmetic to that. So this data is in degree Celsius. So to transform this to degree Kelvin, so you have to say like use, let's say 2 plus 273.15, and you can do all sorts of computation, NumPy computation using from this, and you can apply all sorts of functions to this. Uh, so for example, there is this function gsw dot t90 from t68. So this is a particular function, and so you can just apply this function on this uh, on this data array ds dot sst. So then comes you can also perform mean along a particular dimension. So you can say sst equal to ds dot sst. So you can extract the data array from the data set, and then you can say dot mean axis equal to 0. So along time you can take the average or time mean. So it will give you the time mean or the climatology. You can also say mean along a different axis. So axis equal to 1 comma 2. So mean along the latitude and the longitude, and then just dot mean will return you mean along all the dimensions. So Xarray also offers a feature of in which you can say sst dot mean dim equal to, and then you give the name of the dimension or the coordinate. So it will give you the mean along this particular dimension. So yeah, we saw this last time. So SST, we were trying to plot the mean. So we could imagine computing the weighted spatial mean of SST, because so there will be land points as well. So you can compute the weights as cosine of latitude. So you convert the latitude from degree to radian, and then calculate the cosine, and you multiply this SST with the weight. So it will be broadcasted only in the latitude dimension, because this weights is also a Xarray data array. And if you do it this way, so that would be wrong. You can see the values 2300, 2325. SST cannot be, even if it is in Celsius or Kelvin, it cannot be this high. So the problem is that the denominator needs to be expanded to include the long dimension and modified to account for missing values. So Xarray, it provides you direct means to perform this kind of a weighted reduction on multidimensional arrays. So you would say ds.sst.weighted, and you would say weights. So this will basically apply your weights properly over the and then you can take mean along the lon and the lat dimension, you can say SST weighted dot mean along, and then plot it. So now you can see the values are in degrees Celsius coming in the realistic range of like 16, 17 to 18. You can also do a group by. So for example, if you select a particular for a particular location for a particular lat and lon point, grid point, you make this plot. You say dot plot ds dot sst dot cell lon equal to 300, lat equal to 50 dot plot. That will give you something like this. This has got the seasonal cycle. Now to remove the seasonal cycle, what you would do is you would say you can say dot ds dot group by ds dot time dot dt dot month. So you group this data by month, or you can even say ds dot group by time dot month. And then after grouping it by month, you can compute a mean. So if you compute a mean, it would be a mean along the grouped dimension. So you can say gb dot map. So gb is your this data set group by, and you can say gb dot map np dot mean. So you have to pass a function to dot map, and it would give you this for each month the mean values. So you get these 12 values. And so you can say you can also say gp dot map time mean. So this time mean is a function. It takes in an argument a, it returns a mean along the dimension time. And you can also say gb dot mean dim equal to time. This is also same. So then if you plot the climatological mean, so this is the mean climatology, and this ds underscore mm, which was basically mean along the time. So this is basically this the mean along the time, but grouped by months. So now you don't have in ds underscore mm. So you can see you have lat, lon, and month. Your time is gone. You have taken the mean along time dimension, but you group the times by month, right? So you can see that you plot here ds dot mm dot ds underscore mm dot sst dot mean. You take the mean along the dimension lon, and you plot it. So on x-axis you have month, on y-axis you have latitude. You can also plot the difference between the January and the July climatology, and you can plot also compute the anomaly. So you can say gb equal to ds dot group by time dot month gb minus gb dot mean dim equal to time. So this will give you ds underscore time. Now if you plot for a particular location, you can see the anomaly. So we have already seen this example in the last class. Okay, so then the next thing is plotting and visualization. So you load your data. It has got the dimensions lat, lon, and time. And now this has got three variables: TAR, dt by dx, dt by dy. So the basic plotting, so you can see this TAR is a three-dimensional variable which has got latitude, longitude, and time. So ds dot TAR dot plot, it plots you a histogram. And then ds dot TAR dot icell time equal to 1 dot plot. So if you select the time, if so the index for the dimension time, the index 1. So you should remember it starts from 0. So then it becomes a 2D variable. So then if you just say dot plot, it gives you a nice spatial visualization. You can also plot for a particular longitude. So you can see here we have selected for a particular longitude, and we are plotting on x-axis is time, on y-axis is latitude. You can also plot the for you can also just select the two particular dimensions or coordinates, you can select them by index. So you can say icell time equal to 1, ln equal to 10, dot plot, marker equal to, you can also mention the marker shape. So that will give you this kind of a time series. You can also do this for multiple different latitudes or longitudes. So you can say dot cell lat equal to 40. You can give a list 40, 50, 60. Method equal to nearest, and plot x equal to ln. So in x-axis is ln, and the hue is lat. So you give this hue of lat. So you can see for different lats, we have plotted the daily air temperature. So then we can see that okay, so this is making the subplots. You can do this very easily using Xarray. So you can say monthly means dot tier dot plot, column is equal to month, column wrap equal to 4, column underscore wrap. So then you basically have four months like in a single row, and the each plot is, so each row is it's a column. And so yeah, you can do this for different variables. So yeah, these are the subplots. Yeah, then comes this library Cartopy. So this is very important. So you import this library Cartopy. So you say import cartopy.crs. So you say import cartopy.crs as ccrs, and at the time of either at the time of making the plot or creating the main plot or the subplot. So you give the projection. So here we are given the projection equal to ccrs.orthographic, and yeah, so here we are given the transform. So these are the syntax that you have to give. So this is to ensure if you would want some coastlines, or you would want country, or you want district, so Cartopy has got all sorts of visualization. So you can see here projection equal to ccrs.orthographic, coastline equal to true, like different methods of plotting and providing the coastline or the countries. So then we have Dask. So Dask is basically for if you have large data set, it could be distributed into different chunks. So at the backend, Xarray will be performing the parallel. It would be computing in a parallel manner, but you won't see any of that. So for example, we have this numpy array ones underscore np, and so you create a Dask. So you create a Dask array of that. So you say ones equal to da dot ones, and you say this is a shape. So this is creating a Dask array. Okay, so this one's Dask array. So this is like numpy array, but it has got like it has got so many different chunks. So but here we have not told Dask to divide this data into different chunks. You can tell it explicitly. So you can say what is the chunk shape. You can say 1000 by 1000. So then if you make ones equal to da dot ones shape, so this is the shape of your Dask array, chunks equal to chunk underscore shape. So you see here it has made this Dask array of size 4000 by 1000, but each chunk is of size 1000 by 1000. So you can see chunk is 1000 by 1000. The total array is 1000 by 4000, and its total array is taking the size 32 MB. The chunk is taking the size 8 MB. So 8 into 4 is 32. Now when you call dot compute on a Dask array, the computation is triggered, and so this to transform a numpy array to a Dask array, so you would use this this function dot compute. You can also say dot visualize, so that will basically visualize how many chunks your data has. Also, what you can do is, so you, for example, if you apply a computation to this Dask array, so once is this Dask array which has got 4 chunks. So you say once dot sum. If you visualize that and you want to see what Dask has done, so you have these 4 chunks of ones. So you basically sum all these 4 up. Okay, so these are individually within them, you just sum them up. So this is that sum. Okay, so then these sums then again you do a partial sum, and then these two sums also it does a partial sum, and then these partial sums are then aggregated. So you can see that different workers are working independently to reach a common goal. So you are dividing the task. Now all this computation is hidden from you. Xarray does it on its own, and you can even see a bigger calculation. So if you want to do a ones into ones dot mean, and you want to visualize how Dask will perform this kind of computation in a parallel manner. So you can even create a bigger Dask array. So this is 200,000 by 4,000, and this is the shape. So you can say chunk shape, chunks equal to chunk shape. So chunk shape is 1000 by 1000. So your entire array is of size 6.4 GB. One chunk is 8 MB. And okay, so now if you want to do the big calculation, so you can say this big calculation is big ones into big ones. So dot mean and result equal to big calc dot compute. So it has, so basically it will do it in a, it will occupy and it will use all the available cores. So for example, you have either you have 32 cores or 64 cores in your processors, so that Task will use. Yeah, then it has these data schedulers. I don't think you need to know all of these things because these things happen under the hood. So then, yeah, then comes Dask and Xarray integration. So let's say if you want to, we were reading that data set, air temperature with just this much of syntax xr.tutorial.open dataset. Now to use Dask, you have to specify the chunks. So chunks you specify in this is an argument in this open dataset function. So you specify the dimensions. In how many chunks do you want to break your dimensions? So let's say lat in 25 chunks, lon in 25 chunks, and time equal to -1. So now if you read this data, so you can see that the each chunk is having a size 2920 by 25 by 25, and the total array, entire array is having a shape 2920 by 25 by 53. So thing is, if you want the chunk to take the entire dimension, so you give -1 or you give the particular chunk size. So now if you do this, so you can see your if you plot a mean, so a time mean in a particular dimension, so you can see each chunk has got the entire all the times, right? So along this dimension, so this dimension there is no problem. You can very easily compute a mean. So if you do a dot mean time, so then this gives you a uh, Dask based Xarray data array. So which is basically 53 by 25. So you can see 53 by 25. This dimension is 25, and this dimension is 25, 25, and 3. So because we gave the one, like we asked it to break it into chunks of 25 and 25. So that is why it broke 53 into two chunks of 25, 25, and another one is of size 3. So then you can even slice, you can very easily slice the values from for that particular data array. You can so you can compute the mean, you can compute rolling mean. So all the functions of Xarray, they will apply. They are straightforward. You can implement on Dask based data arrays. But once you do dot compute or dot values, so then everything will come to one processor. So the Dask parallelism will be over. This will take some time also. Or you can even say dot load or dot compute or dot values. So yeah, that was about Dask, and then comes this important function called apply ufunc. Okay, so apply ufunc, what it will do is, so let's say you want to perform a computation along a particular dimension, and you want to use all the different processors available. So you would say that xr.apply ufunc. So this is the function that you want to apply, and then you have to give the data array. And okay, so we'll see this. Yeah. This is right. So you will say xr.apply ufunc. You give the function. So dask.array.mean, some function you give, either your function or a predefined function. You give the data array on which you want this to be applied. You give the input core dimensions, so the dimensions along which you like this data you want this function to be applied to. So you want to apply this mean along this time dimension, and you say dask equal to allowed. So then this will return. So if you pass, so this to this function, if you pass this ts.air, this will basically return you latitude by longitude data array, which is mean in time. So this will use all the processors in a parallel manner. So that was all about Xarray and Dask. And if you have any questions, you can ask, or otherwise we will close this